All right, we're just going to start our third unit. This is all about graphing quadratic functions. So just to give you at the very top, there's two different forms that graphs can be presented to you in. One's called standard form, which looks like this: y equals ax squared plus bx plus c. And the other version is y equals a times x minus h squared plus k. If you guys have the standard form, this is this format all multiplied out and simplified. So vertex form allows you to see the vertex. HK is the vertex. And I'm just going to little note here, A is the same in both formats. So A here and A here will be exactly the same number. Now we're going to focus on just graphing some basic graphs today, and so we're not going to have any shifting quite yet, but we'll just do some basic stuff here at the beginning. So to write an equation in standard form, this is called factored form right here. This is just a little foil, a little review, some of the stuff we've been working on in the first unit. So you can FOIL, or if your preference is to draw a box, you can do that for this problem as well, but I'm just multiplying everything out and then I'll simplify it. So here I'd get x squared, 4x, negative 3x, and negative 12. And so in standard form, if I combine my like terms here, x squared, negative 3 and 4 is going to give me plus 1x and then minus 12. So just multiplying that out. Now, the question next to us, this is in vertex form. Now, this is a little tricky, so I want to multiply this out to get rid of the parentheses to put it in standard form. So if I'm squaring x plus 5, and that's in parentheses, you cannot do a distributive property with that exponent because you'll completely mess up the middle part of that. So when you're multiplying something or squaring something, multiplying it by itself, you got to multiply it by itself. So I'm going to do a FOIL here in 1 second. Okay, I'm going to keep the 3 out in front. Again, if you prefer a box, you can use a box. I'm going to go ahead and FOIL on this question just so I do one of each. X times x gives me x squared. X times 5 gives me 5x. 5 times x gives me another 5x, and 5 times 5 gives me 25. And just real quick before I distribute the 3, I'm going to go ahead and combine my like terms. And the 3's getting multiplied by each of those 3 things. We get 3x squared plus 30x plus 75, then minus 7. And the only other thing I can do there is simplify a little bit. This would become 3x squared plus 30x, and then 75 minus 7 is going to give you 68. Okay, now just to go through real quick, these are standard form. It says state the quadratic, linear, and or constant term. So I'm just going to go back through and show you guys how to do that real quick. The quadratic term, I'll just write a Q, is the term with the x squared. So here, for this question, just x squared. The linear term is with your x, so just 1x here, and your constant is your plain number, so for this example, it would be negative 12. Now, over here, quadratic is going to be the squared term, so 3x squared. Linear term is the plain x, so 30x, and then your constant here is any plain number, and that's 68. So if you're asked to identify the different types of terms, that's what's going on there. Okay, now we're going to get into a little bit of the graphing. So parabola is just the name for the graph of a quadratic. Quadratic means my highest power of x is just to the second power. Now, for these questions, your axis of symmetry is going to go right through the middle of the parabola. It's a symmetry line. And I'll come over here and draw it on the graph to kind of illustrate this. So symmetry line, and it's vertical. And the vertex is the maximum or minimum point. And that depends on how the graph turns. So let's come over here. The axis of symmetry is going to go right through the middle of the parabola. So if I were to fold it in half, it would match up on either side. So for this example, right up the middle, it's always x equals, and then it's always going to match the x-coordinate of the vertex because it has to go through the vertex. So this is just on a 3, so x equals 3 is your axis of symmetry. The actual vertex right here is, in this case, a minimum point. It's the lowest point on the graph. If the graph turns the other direction, it's going to be a maximum point. So here you're just identifying the coordinates. This is 3, 2. So I'm just going to write these. This is 3, 2. Axis of symmetry, x equals 3. Axis of symmetry has to be the equation of a line, so I need to see x equals some number. And then corresponding points, really quickly. So there's 2 points graphed on here, P and Q. A corresponding point, if you guys remember this from geometry, if you have a little, it looks like an exclamation here, but it should actually be what we call a prime. So it's just like a little, almost looks like a little 1 power, but it's to indicate a reflection. So here's P. If you can find your axis of symmetry, P prime is the reflection over the axis of symmetry. So if this is my point P, reflect that over your axis of symmetry, and that's P prime. So this is going to be, to write down the point, 5, 6. Same thing, here's Q. Now this is going to go the other direction, but it's just a reflection over your axis of symmetry. So 3 spots away, 3 spots away, that'd be your Q prime, and the point there is 0, 11, to write that down. Now, we're going to start with a basic graph, just what we call the parent function. Your most basic quadratic, no frills, nothing, would just be y equals x squared. To be a quadratic, you have to have the highest power of x be squared. So I'm just going to give you guys a little design here with the table, and we're going to plug in each of these values to get the y. What I want to remind you of, when you square something, make sure, especially if you're working with a negative, put that in parentheses and then square it. So this should become positive 16, positive 9. Negative 2 squared, positive 4, negative 1 squared, 1. 0 squared is just going to be 0. And then this will just repeat. 1 squared is 1, 2 squared is 4, 3 squared is 9, and 4 squared is 16. So if you guys want to take a second, come over here, graph this. I'm going to push pause for a second to give me some time to graph this. All right, now I went ahead and graphed what I had in the table, so I just paused to do that. And to the side, I know it doesn't ask you this, but I went ahead and wrote down the domain, the range, the vertex, the axis of symmetry. Domain left to right, this is going to eventually open up and cover the whole x-axis, so negative infinity to infinity. Range, you wouldn't touch any part of the graph until you just started at the vertex there at 0, and then the rest of the graph points up forever, so that goes from 0 to infinity. Vertex right there at the origin, 0, 0. Axis of symmetry is actually the y-axis right down the middle here. The actual equation of that line, though, is x equals 0, because all the x coordinates are 0, nice vertexal line. Okay, now before I flip over to the next page, I'm going to show you guys without creating a table, just a little cheat for how to do this in terms of the graphing. So here's my vertex. Just going to show you a little pattern here. To get to this next point, I could argue this on either side. I'm going over 1 and up 1. From that point, I go over 1, up 3. From that point, I go over 1, up 5, and then from that point I go over 1, and if you count up, that'll be 7. So there is a pattern to this that works for any quadratic, and I usually just write the first 3 numbers, but if I continued this pattern, I'm just going up by 2 every time. So like the next one would be over 1 up 9, over 1 up 11. You can continue the pattern, but it's always over 1 up 1, over 1 up 3, 5, and it's odd numbers. And so I usually write this as a pattern. I call it 1, 3, 5, and we're going to talk more about that on the back. But you can see here that pattern continues, and if we had a bigger window, we'd have even more. All right, so I'm going to actually, oops, sorry, I'm not all the way down. Quadratic graphing pattern, like I was saying. This is 1, 3, 5, 7, 9, and you can continue the pattern. And it's affected by the a value, and that's the term or the number in front of the x squared. So the pattern will work every time, and if that value in front of x squared is not 1 like it was on the front, then that affects the pattern. And we're going to get into this here on this first example. Okay. Let me start here and let me rewrite this real quick. I'm going to write this in vertex form. I'm going to write this as x minus 0 squared minus 5. So x is not having anything with a shift here, and the vertex, it's just like what we did for absolute value, opposite copy. So x coordinate here is going to be 0, y coordinate is going to be negative 5. That's your vertex. Okay, now if you do like we were doing in the last unit, absolute value, that has a consistent pattern. Quadratic, because we're squaring, has this 1, 3, 5 pattern. Now, in terms of this question, my a value is just 1. So 1, 3, 5, if I multiply that by 1, that's going to be 1, 3, 5. So once you got your vertex, here's the rule. Just go over 1, and then you go up 1. Over 1, then you go up 3. Then you go over 1, and then you go up 5. Always over 1, and when I say over 1, you actually do that on both sides of the vertex. So here, I'm going to go over 1, up 1 on either side. Plot that point. Now, from that point, you just put over 1, up 3 on either side. And then same thing, over 1, up 5, and then we've got a really good idea of our graph. Now, sometimes you can fit more points on, sometimes not. It just kind of depends on the question. Okay, now here, let me just rewrite this real quick. This would be x minus 0 squared plus 7 in vertex form. So the x-coordinate of the vertex there is 0, the y-coordinate is 7. If you don't have any term in the middle with an x, it just keeps the vertex right on the y-axis. So 0, 7, there's my vertex. Okay, now here, a is negative 1. So I'm just going to alter my pattern a little bit, and I'm going to multiply it by negative 1. So just literally think about like doing a little distributive property. So like negative 1, negative 3, negative 5. So all this means is it's always over 1, but now I'm going to go down 1. And then you'd go over 1 from that, down 3, and then I keep going over 1, down 5. So I'll show you on the graph. So over 1, down 1 on either side. Over 1, down 3. That negative just flips it over. And then over 1, down 5 would be right in here. And I could keep going and do over 1, down 7, but this is plenty to get a good idea of what the shape of the graph should look like. All right, now what to do if your pattern has an a value which is not 1. And this is not hard. Literally, I kind of wrote this at the top, so I'm just going to jot it down again. Just take whatever is in front of your squared term, and you multiply that by the pattern, and then I'll show you how this works down here real quick. Okay, now this would be 3. X minus 0 squared plus 0. The vertex here is just going to be 0, 0. The 3 being my a value is going to affect my pattern. So I'm going to do 3 times that 1, 3, 5. So the pattern I'm going to use for this graph is going to be 3, 9, 15. I'm going to bet the 15 is not going to fit on the graph. The vertex here is just going to be 0, 0. There's nothing shifting that graph left, right, up or down. So 0, 0. Okay, now here's my pattern. From the vertex, over 1, up 3 on either side. Then from there, just follow that pattern. Over 1, up 9. Let's see, we're going up to the 9. Be way up here. Now, with the window you guys have on this, we're not going to be able to do the 15. There's not enough room, so this is just really narrow. Alright, let's switch over to part B. We're almost done here. I'm going to just rewrite this in vertex form real quick. This will be x minus 0 squared minus 7. Opposite copy, here's my vertex, 0, negative 7. Okay, now my a value is 2. So we're doing 2 times our 1, 3, 5. So my pattern here is going to be 2, 6, 10. So just from that vertex, it's always over 1, and I'm going to go up 2, over 1, up 6, and we're not going to be able to fit the 10 on this one, but we would go up over 1, up 10 if we kept going. This is plenty of points though. Get an idea of the graph. I think at the top it'll say something like graph at least 5 points. There's at least 5 points right there. Alright, and I've got one more. Let me write this in vertex form here real quick. So 1/2 x squared, opposite copy. This is going to be my vertex. And for this one, this is always tricky for people, so let me explain this one real quick. So my a value is 1/2. So this is going to work the same way times the 135. Okay, now I don't want to write these as a fraction because I think that throws people off and they try to use it as a slope. So here's what you want to do. 1/2 of 1 is 0.5. 1/2 of 3 is 1.5. and 1/2 of 5 is 2.5. Whoops, I'm off the screen, sorry. So this is always over 1. If you've got fractions like this, we're just going to do a little estimation. So I'm going to go over 1, up 1/2. So just go like midway. And then from there, over 1, right on the halfway mark, up 1.5 would actually put me on a nice number. So I'm going over 1 on the halfway mark, up 1, and then 1/2. And so we do that on both sides. From there, over 1, up 2.5, just kind of estimate. 1, up 2.5. And you'll see this a little bit wider. This is a stretch, or this is a shrink, excuse me. The previous question was a stretch. We'll talk more about that next week. So here's what we're doing, just the pattern and some graphing, and then we're getting our basics out of the way.